Hi and welcome to this presentation by the Maths Engineer. Today we will be looking at kinematics. The definition of kinematics is as follows. Kinematics is a branch of classical mechanics that describes the motion of points and objects. Often referred to as the geometry of motion, it focuses on movement through variables such as distance, time, displacement, velocity and acceleration. So let us look at each of these in turn. Firstly, let us consider distance and displacement. Distance is a scalar quantity that only has magnitude, but displacement is a vector as it has both magnitude and direction. Consider the distance and displacement of the car in the following diagrams. First, we must assign which direction is positive and which is negative. In the case as the car moves from left to right, it is assigned as positive. When the car travels from right to left, this is assigned as negative. We must also assign a fixed origin which is called the zero position. In the first diagram, when the car moves relative to the origin, it has travelled a distance of 100 metres. Its displacement is also 100 metres. In the second diagram, the car has travelled an additional 70 metres, but in the other direction. Thus, the total distance is 100 metres plus 70 metres equals 170 metres. However, its displacement is not the same. It is 100 minus 70 metres equals 30 metres. This means that when considering displacement, it is always referred from a fixed origin, but the distance can be measured as the sum of the entire distance covered. Now let us look at some graphs that show the relationship between distance, velocity and acceleration. Graphs for these are always measured with respect to time. Time is nothing but the interval between a starting time and a final time. So we have the distance time graph here on the left. This graph is a straight line graph with time on the horizontal axis and distance on the vertical axis. Because the line is straight or linear, the object is travelling with a constant velocity. We have the point on the graph of 3, 6. This means that in 3 seconds we have travelled a distance of 6 metres. After 3 seconds and travelling 6 metres, we see that the line has a slope or gradient of 0. This means the object is no longer moving. So how do we calculate the velocity? The velocity is nothing but the steepness of the line, which is the distance travelled divided by the time taken. Or we could write it like this. V equals D2 minus D1 over T2 minus T1. D2 is 6. D1 is from the origin, so it's 0. T2 is 3. T1 is again from the origin and so is 0. So we write V equals 6 minus 0 over 3 minus 0, which means V equals 2 meters per second. The velocity is always 2 meters per second throughout the duration of the distance travelled and is shown by the second graph here on the left. As you see, this is a straight line graph that has a gradient of 0, which means we are moving at a constant speed. This also means that there is no acceleration and thus the acceleration is 0. Next, we will move on to cases where the graph is no longer linear and thus there will be an acceleration.